So last time I think I said something along the lines of, well, if you get this, the rest, this is a decent start and the rest shouldn't be too hard. I think I said something like, oh, well, the y-axis shouldn't be too bad. And really, if the y-axis wasn't that bad, why didn't I just do it myself? Like, sure, I have been working on 5 games at the same time, as well as replaying Dark Souls and getting destroyed by Ornstein and Smough and getting to the end of Fire Emblem 1 just to realize that I can't beat the game because nobody can even hurt the final boss. Anyway, let's figure out how to look up and down. Okay, so here's our thing from before. We're gonna download this. So I think we already are rotating on the y-axis, and what we want right now is we want to figure out how to rotate on the x-axis. But first, let's maybe try and adjust this, because this is only taking up a small portion of the window, and let's make it the entire window. Canvas dot width is equal to window dot inner height. Okay, how do I know to use inner width? The real answer is because I looked it up on Google a couple days ago when I was trying to do my own game. What? Okay, I screwed up the order. Why do I? What is? Great, but now we have these scroll bars here. There's a little bit of a margin at the top of the page. How do we get rid of that? One way is we could just add style up here, add body, margin 0, I think. Would that work? There it is, no scroll bars. Okay, whoa, what is this? So, the issue right now is that I've got to adjust the screen bounds, or how do I define the center here? Okay, yeah, here it is. Center of screen X, center of screen Y. We're going to make this canvas dot width divided by 2, canvas dot height divided by 2, and then the screen distance is center of screen X. And oh, we're defining it again down here. Okay, look at that. Does something feel off? Do I feel like I'm moving too slowly? You know what I think happened actually? Is that I made it widescreen, and so you can't use the same field of view now because I'm using a 90-degree field of view for larger area, so I need to make the field of view larger. I don't know, let's try 800. Is that a good number? Still feels slow. 700. There. Alright, I like 700. So I like using the WASDA. I'm just gonna add WASDA. Will that work? That may work. '87, '83, '65, '68. So 87, 65, 68. Again down here. Now I can use the WASDA. Now I want to look up and down. Alright, I'm gonna do the hurdle. Why do I think this is Sunday Bloody Sunday? Nope. Maybe it's sweater weather. I just didn't know this song. Okay. How does any of this work? Ugh, I don't even have any idea what I'm doing. Oh my god, what in the world? I like this one. This is good. It's like Zod at the end of Superman where I'm trapped in the mirror. Oh, what did I do? I don't know. Maybe it should only be X1 diff. Oh, whoa, okay. Now we're doing a roll. It's so weird. What is happening? Let's just undo everything. I know what I can do is we can add another listener. Call this mouse move. If I can call it that way. Okay, so instead of offset X, I say movement X, movement Y, I don't know, X turn. Say fpeng equals X turn, and just set X turn equal to 0. What is happening? Okay, so that's not good. Okay, let's divide this by canvas dot width. Oh, you know what the problem is? We're adding X turn when we really should be, yeah, we should be plus equaling it to the angle instead of setting it equal to it. There it is. Now it's too slow. Let's just define some variable here. We'll call this turn mult. Let's just set it to 3 and then multiply X turn by that. And okay, that's about good. I'm using the mouse to move around. You know, I'm not capturing my mouse, so you won't even be able to see this. But we should only be moving the camera when the mouse isn't captured, and right now my mouse is on the screen and I'm moving around, so that's not good. Oh wait, I could check document.pointerLock element equals canvas. Can I just do that? Oh, look at that. Alright, so now it only moves if the pointer is captured. And let's copy this now and add this for Y turn. Find that up here. Do this function. It says first person angle. Let's do first person Y angle and define that. Let's make it so that left and right are now strafing controls. So I think all I have to do for this is just change the sines to cosines and the cosines to sines. No, that didn't work. Oh, right, yeah, I forgot. The minus signs here. Hopefully this will work now. Left, right. And does it work like... No, it does. What is happening? I'm just getting something wrong with the minus signs in here. I don't know. This should be like a minus. And then this should be a plus. Let's see if that works. Yeah, okay, that worked. Now, you might be wondering, how did you know to do that? The answer is, I don't know, dude. Whatever, it works. Just copy me. Okay. Have I delayed this long enough yet? Actually work. Okay, this feels so weird. What? Okay, I'm forgetting to set Y turn back to 0. That helps with the directional movement. What it doesn't help with is this. Oh man, whoa, whoa. Yeah, okay, it's weirdest when you're turned sideways, which I think shows that I did something wrong. I don't know, when you look up and down, it shouldn't be like rolling the camera. Maybe it's because I correlate it with Z and it should be correlated with X. I hope this isn't just like even weirder. Okay, no, it is. Whoa, that's interesting. This is great. I love like the weird visuals that we're generating just by bad coding. Oh my gosh. Probably what I need to do is I need to like actually use my brain. Alright, you know what? Let's take a break for a second and let's just clean up some code. So I don't need this draw 3D line function anymore. That's not necessary. I don't need draw prism anymore. So now let me fix draw 3D quad. Right, so I don't like that there's so much repeated code here. So let's have draw, or not draw 3D point, but like get 3D point, x1, y1, and z1. Just like copy this, copy this, copy this. This in here. False. Else we're going to return disp x1, disp y1, translated z1 as well. And then we can say get 3D points, x1, y1, right? And then just like do this for 4 of them in a row. Right, because like look how much code I can delete and clean out here. Say D12, D10, D11. Yeah, I guess giving it all the inputs is probably pretty important. Okay, so, yeah, this looks about right. I mean, this looks freaking cool, let's be real. Like, I don't know what I'm looking at, but this looks trippy AF. What? How did I make this mistake? Like, how does this happen? How does this, I don't, like, I couldn't replicate this. Like, this is so weird looking. I don't know what I'm looking at, but we've got, like, the weirdest freaking crap, like, moving up and down. Like, what is this? How did I break it this bad? Speaking of Breaking Bad, I should just look at Breaking Bad memes instead. What the hell? Like, why? Why does it do this to me? I mean, oh, that's interesting. That is an interesting thing to have happening. They're like shooting up into the sky. Oh my god. What the hell? 0, 1, 0, 0. Oh, oh, oh. Aha, yeah, okay. Gotta make sure that you check your outputs. And okay, now it's normal and boring again. Wow, it's surprising how easy it is to completely corrupt everything. But look, now our Draw 3D quad code is much simpler, right? Right, because now our points are all consolidated into this one piece of code, right? Because the way that we draw each point doesn't change. All you're doing when drawing a quad is just drawing 4 points and connecting them. So this is also nice because I now only have to change one variable instead of 4 each time. So instead of doing y1 and x1, let's try y1 and translated z1. Now, once again, I don't know what I'm doing. Okay, yeah, this almost works. This reminds me of like how Duke Nukem 3D on Xbox 360 does its 3D, where it's just like not correct. Also, I gotta like fix this weird awkwardness here. Out of curiosity, what if I divide this translated z value by like 2? What would happen? Okay. Interesting. Oh, we have to get his P! Okay, what if instead of dividing by 2, we multiply by 2? Okay, this actually looks better. So yeah, I'm also noticing that I'm getting this weird bug where this pillar is actually going through this other one, and I really have no idea how that can be happening, so I gotta fix that too. Before I try to like figure out what's even happening, let me go and fix this screen distance thing to get this out, into a number that calculated. So let's calculate that number somehow. Calc point of view. And we're gonna give it, I don't know, the degrees of the point of view. So let's pretend we have a top-down view, and this is our character's field of view from above, and this green line over here represents the screen in terms of width. So the green line is the canvas width. If we take half of that, right, then this right here is canvas width divided by 2, which we could call HW so that I don't have to write that. And the variable that we're trying to figure out is this blue line right here, which is our screen distance. And what we know and what we're giving it is the field of view, which, oh, right, not point of view, field of view. But we're only really going to be calculating half of this because this makes a right angle with the screen. So this right here is our angle divided by 2, or we could call it HA. So because of trigonometry, this up here is the hypotenuse, which we don't care about. This right here is screen distance is the adjacent side. So this is our adjacent side. And the half width, the canvas width, is our opposite side. So opposite over adjacent, right, by the rules of SOHCAHTOA. And that's the ratio that we calculate when we do tangent of our half angle. Yeah, okay, but let me just like rewrite this in terms of our variables that we just determined, which means we can multiply by SD and then divide by tangent, and we get this. Screen distance is equal to half the width of the canvas divided by tangent of half of our field of view's angle. So I forget if this is going to use degrees or radians is the problem. So let's go and verify that in the actual console. So let's do math.tangent of 45. Huh, that's interesting. Okay, it's using radians. So let's get that. Right, it's the degrees divided by 180, not the pi, return that. So deg to red, deg. What's our equation again? Let's just write it all out, I guess. Let's call this ha, just so it matches. Deg to rad divided by 2. HW divided by math.tangent of HA. And then we're going to return that. I think 120 is a decent field of view. Calc field of view 120. And okay, this looks about the same. So here I'm drawing pillars on either side, but let's also draw some pillars up above. So let's increase our y value, because there we have some pillars above us. And you can see that if we look straight up at them, like, it's not correct. Let's take another break. I want to be able to run, because running is fun, right? So what number is shift? 16. So let's just put in shift. Let's create the shift variable. Then we just say if shift, then the walk speed times equals 2. So you walk twice as fast. We can just get rid of turn speed. Alright, cool. So yay, now shift makes this run. And also, why does this happen sometimes? Okay, at this point I'm just trying random stuff. Like, why not just put translated C1 in a math.tangent value? Why not? And, okay. That looks good. I think that's the right idea. Neato. A little buggy. Thought about it some more, and I just realized that let's assume that this is a top-down view. And essentially, and I'm going to go over what I was doing before to get just the y-axis 3D, or, you know, turning left and right. So the yellow guy is our view. The green thing is our pillar or line, whatever. This is all from the top down. And so let's imagine that we rotate this. This is kind of what we're doing, is we're rotating it into the view, right? We're rotating it with the angle into the view, and then checking to see, okay, well, is it in front of us? If it is, draw it. If it's not in front of us, then don't draw it. Essentially, that's kind of what's happening, right? And the way that this works is that we're using a rotation formula, and the rotation formula is these two lines. But right here, you might notice I'm trying to like just add another line, right, when I change the axis to the y-axis, but that shouldn't be what I'm doing, right, because I'm just doing the rotation formula on one coordinate. I need to do this on both coordinates, right, and here I'm doing on x and z because I'm rotating on the y-axis, so the y-axis is absent from this, right, but here I'm rotating on the x-axis, right, so I'm saying y and z, but I need to change the z value as well. So I actually did this and wrote this out. So I changed translated z to just a mid translation point because it's just, we're going to change it later. We're down here. And we use that as sort of an intermediary. And basically what we're doing is we're just copying the equation above so that it's two lines, which is what you need to rotate it on the x-axis, right? And now that we've done that, and I refresh the page, right, you can see it actually looks like an actual 3D engine, and things are looking normal, and I'm actually able to look up without things looking so strange and distorted. So this is now correct. What's not correct is the weird Z fighting going on and all the flashing. So I gotta go and fix that next. I think our problem is right here. Right, I'm saying D1 of 2, but I should just be saying D1. I think that's because of the way that I'm returning false. I'm not returning 0, 0 false. I'm just returning straight false. That'll fix it. Okay, I don't see the same issue anymore. Okay, and then the other issue here, this looks like a Z fighting issue more than anything else. And Z fighting issues are still things that happen in your average Unity editor. But even so, let's just see if we can do something about this. So I think the reason why Z fighting happens is because of floating point values. Basically, the two values are the same, but differences in mathematical precision causes them to swap between one and the other. What you might want to try and do is make it so if they're about the same, it should round and then preserve that rounding each time. The question is, how precise do we want to go? Let's say we're precise down to a 10,000th of a unit. Let's make this a function. So what? N times precision, right? And then we parse into it to make it into an integer, which cuts off any extra values. Although that could have some problems now that I think about it. That's when, okay, instead of parsin, actually, we want math.round. Okay, and then we divide by our precision, and then we return that. So maybe this will work, I don't know, we'll see. Precision round takes multiple arguments. Okay, and it looks like it mostly fixes it, except for negative positive issues, right? So you can see it switches right when I decide to look up versus down. Okay, so there's a problem with my implementation here. And so here's a sort of diagram that kind of illustrates that. So imagine that these prisms here, the red one and the black one, imagine they're actually, of width nothing, and that they're just two squares that we're trying to draw, two quadrilaterals. And they're intersecting each other like that, and we're looking at it face on. There's no way that we can draw that in the way that we are trying to draw it. Because if you drew the red one first, the black one would cover it up, and if you drew the black one first, the red one would cover it up. So I think, and this might just be like one specific case, but I think what I need to go and do is subdivide these things. But it doesn't really matter that we have subdivisions, because it's still getting weird at times. Drop it down, okay? This is gonna chug. Yeah, this is chugging. it does not look any better. It looks significantly worse. I feel like that's a strong possibility. So I don't know what's going down at the bottom here, but this doesn't seem to be the solution that I thought it would be. You know, this is not a very efficient solution. You know, you don't want to be subdividing all of your polygons like this.
Check if any of them, at least one of them, are greater than 0. We got this again. Okay. It's an interesting thing. Trying to make it so that the objects don't disappear if part of them is off screen, which is the problem with this solution right now is that it doesn't work. But it does cause very strange, weird bending, which is kind of cool.